Today, we will learn some special cases related to the area of a rectangle. Take a rectangular piece of paper of length 10 cm and breadth 6 cm. Cut the rectangle along its diagonal to get two triangles. Superimpose one triangle on the other. After adjusting, you will find that they cover each other completely. What does this tell you? Think for a while. You are absolutely right. Here, both the triangles are congruent. Since they cover each other completely and exactly, we can also say that both triangles are equal in area. Since the rectangle in question is being divided into two equal parts, we can say that the area of each triangle is half the area of the rectangle. Or in other words, the sum of the areas of the two triangles is the same as the area of the rectangle. The area of each triangle is half into area of the rectangle. In this way, the area of each triangle here will be half into length of the rectangle into breadth of the rectangle. Thus, the area of each triangle will be half into 10 cm into 6 cm, which is equal to 30 square centimeters. Now take a square piece of paper of side 8 cm. Draw both its diagonals and divide it into 4 parts. You will get 4 triangles. Are they congruent to each other? Think for a while. Let me tell you, if we place all the 4 triangles, one on top of the other, they will cover each other completely and exactly. Therefore, we can say that since all 4 triangles are congruent to each other, they are equal in area. Since one square is being divided into 4 equal parts, we can say that the area of each triangle is 1/4 of the area of the square. In this way, the area of each triangle will be 1/4 into area of the square, which means 1/4 into side square, that is 1/4 into 8 cm square, which is equal to 16 square centimeters. Similarly, a rectangle ABCD of breadth 7 cm and length 12 cm is divided into 2 parts as shown in the figure. Here, AEPQFD is congruent to CFQPEB. Can you tell me what will be the area of each part? Think for a while. Your answer is absolutely correct. Here, the rectangle is divided into 2 congruent parts. Therefore, the area of one part is equal to the area of the other part. We can conclude that the area of each congruent part will be half of the area of the rectangle. Thus, the area will be half into 12 cm into 7 cm, which is equal to 42 square centimeters. Now look at the square given here. In this, the square ACEG is divided into 8 congruent parts. If the length of the side of the square is 10 cm, what will be the area of each part? Think for a while. Let me tell you. Here, the square of side 10 cm is divided into 8 equal parts. Since all parts are congruent to each other, we can conclude that they are equal in area. Since the area of the square is divided into 8 equal parts, therefore, the area of each part will be 1/8 into area of the square, which is equal to 1 by 8 into 10 centimeter into 10 centimeter, which is equal to 1 by 8 into 100 centimeters square, which is equal to 12.5 square centimeters. Now find out for yourself if all the parts of the rectangle of length 18 centimeter and breadth 12 centimeters are congruent to each other. What will be the area of each part? Today, we learned about some special cases related to the area of a rectangle.
Today we will learn calculation of area of adjoint figures. The amount of surface enclosed by a closed figure is called its area. Look at this rectangle. The length of this rectangle is 5 cm and breadth is 4 cm. If we place it on a squared paper consisting of squares of side 1 cm, then we see that the boundary of this rectangle encloses 20 squares. We say that the area of rectangle is 20 square centimeter, which we denote as 20 square centimeter. But if we observe the figure, we find that product of length and width of rectangle is 5 centimeter multiplied by 4 centimeter is equal to 5 multiplied by 4 multiplied by centimeter multiplied by centimeter is equal to 20 square centimeter. Considering both conditions, we can say that the area of a rectangle is length multiplied by breadth. If we represent the length with L and breadth with B, then the area of rectangle A will be L multiplied by B. Just imagine which shape will be obtained if length and width of rectangle are equal. Think. Yes, if we do this, then all the sides of rectangle will be equal and so we get square. In this case, we say that area of square is equal to length of the side multiplied by length of the side is equal to length of the side square. If we denote the length of side with A, then the area of square will be A square. Now look at this figure. Can you tell what will be its area? Think. Let me tell you. We can divide this shape into two rectangles in this way. Let's name them. This is rectangle ABCD and this is rectangle DEFG. We take the length of rectangle ABCD as 8 cm and width AD is equal to AG minus DG is equal to 5 minus 2 cm is equal to 3 cm. Similarly, the length of rectangle DEFG is 3 cm and the width is 2 cm. In this way, the area of rectangle ABCD will be length multiplied by width is equal to 8 cm multiplied by 3 cm is equal to 24 square centimeter, and the area of the rectangle DEFG will be length multiplied by width is equal to 3 cm multiplied by 2 cm is equal to 6 square centimeter. Therefore, the area of complete figure will be the area of rectangle ABCD plus the area of rectangle DEFG, which is equal to 24 cm square plus 6 cm square is equal to 30 cm square. Now, can you find the area of this shape? Think. Let me tell you. Required area is equal to area of square ABCD minus area of square EFGH. Here, the area of square ABCD will be side square, which is equal to 6 cm square, which is equal to 6 cm multiplied by 6 cm is equal to 36 square centimeter. And the area of square EFGH will be the side square is equal to 2 cm square is equal to 2 cm multiplied by 2 cm is equal to 4 cm square. To find the area of the figure, we will subtract the area of the square EFGH from the area of square ABCD. Similarly, the area of figure AHGF EBCD will be 36 cm square minus 4 cm square is equal to 32 cm square. So today we have learned the calculation of area of adjoint figures. In the next video, we will see some examples on it. Today we will see some interesting examples related to the area of adjoint figures. Perimeter of a rectangle is 36 cm. Its length is 2 cm less than 4 times its width. Find the area of the rectangle. To find the area of a rectangle, we have to find the length and width of the rectangle. Let us consider the width of the rectangle as x. It is known from the question that the length of a rectangle is 4 times the width and 2 centimeters less. Since we have considered the width of rectangle as x, we can write the length of rectangle is equal to 4x minus 2. We know that the perimeter of rectangle is 2 multiplied by length plus width. We are given the perimeter of rectangle as 36. 2 multiplied by length plus width is equal to 36 centimeter. That is 2 multiplied by 4x minus 2 plus x is equal to 36 centimeter. On simplifying it, we will get the width of the rectangle, that is x is equal to 4 centimeter, and the length of rectangle, that is 14 centimeter. In this way, the area of rectangle of width 4 centimeter and length 14 centimeter will be length multiplied by width is equal to 14 centimeter multiplied by 4 centimeter is equal to 56 square centimeter. Next example, the length of a square wall is 9 meter. The wall has a rectangular window of 300 centimeter length and 200 centimeter width. If the wages for painting an area of 1 meter square is rupees 3, then what will be the total wages for painting the entire wall? First, we will find the area of the wall. The area of a square wall with side 9 meter will be side square is equal to 9 meter square is equal to 81 square meter. But this entire area will not be painted. The area of window will not be painted. To find the total wages of painting the entire wall, we have to subtract the area of window from the area of the wall. Let us find the area of the window. Since we want the result in square meter, so we will convert the length and width of the window into meter. Since 100 centimeter is equal to 1 meter, therefore 1 centimeter is equal to 1 by 100 meters. In this way, the length of window will be 300 centimeter is equal to 3 meter and the width of the window will be 200 centimeter is equal to 2 meter. Therefore, the area of the rectangular window is length multiplied by width, which is equal to 3 meters multiplied by 2 meters is equal to 6 square meter. Now, the area of wall excluding the window will be area of the wall minus area of the window is equal to 81 square meter minus 6 square meter is equal to 75 square meter. That is, it will be painted on 75 square meter and the painting wages will be at the rate of 3 rupees per meter square. 3 rupees multiplied by the area of painting wall is equal to 3 rupees multiplied by 75 is equal to 225 rupees. Today we have seen some interesting examples related to the area of adjoint figures. In the next video, we will see some misconceptions and some mistakes related to it. Today we will see some misconceptions and mistakes related to area of adjoint figures. Misconception 1. If the area of a shape is reduced, will the perimeter also get reduced? Some children think that there is direct relation between area and perimeter of a shape. They think that if the area of shape gets reduced, the perimeter of shape will also get reduced. So, they answer option 1, which is a wrong answer. Suppose we took a square paper of side 4 cm. Its perimeter will be 4 multiplied by length of side is equal to 16 cm. If we remove an equilateral triangle of side 2 cm from this paper, then the area of remaining shape will be less than before. But now the perimeter of shape will be 18 cm. So in this case, perimeter increases and area of figure decreases. Now suppose we remove a rectangle of length 4 cm and width 1 cm from square of side 4 cm. Then the area will get reduced in this case also, but now the perimeter of this shape will be 14 cm. Now in this case, the perimeter is reduced by reducing the area. Considering all these situations, if the area of any shape is reduced, then we cannot tell whether the perimeter will increase or decrease. Hence, option 2 is the correct answer. Misconception 2. If the length of the side of square is increased by 2 times, then how many times will the area increase? Some children think that by increasing the length of side of the square by 2 times, the area of square will also increase by 2 times. That's why children answer option 1, which is the wrong answer. Suppose the length of side of a square is x. The area of this square will be the square of the side, that is x square. If we multiply the length of side of square by 2, then the new length will be 2x. Now the area of new square will be 4x square. If the area of two squares is compared by division, we find that new area is 4 times larger than the first area. In this way, option 2 is the correct answer to the question given. Common mistake. Ignoring units. The area of a wall is 100 meters square. What will be the cost of painting it at rate of 10 rupees per 1 centimeter square? Some children ignore the unit while solving the question. Here they get 100 rupees multiplied by 10 is equal to 1000 rupees for painting the wall, which is a wrong answer. Here the unit of area of wall is in meter square, but the rate is given based on unit centimeter square. Therefore, first we must make the unit same by conversion. 1 meter square is equal to 1 meter multiplied by 1 meter. Since 1 meter is equal to 100 centimeter, therefore 1 meter square is equal to 10,000 centimeter square. Thus, 100 meter square is equal to 10 lakh centimeter square. Since the cost of painting 1 centimeter square is 10 rupees, the cost of painting 10 lakh centimeter square will be 10 multiplied by 10 lakh is equal to 1 crore rupees. Today we have seen some misconceptions and mistakes related to area of adjoint figures. Today we will learn perimeter of adjoining figures. Perimeter is derived from the words peri and metron. Peri means around and metron means measure. In this way, the total length of a boundary of a closed figure is called its perimeter. Look at this figure. The total length of its boundary can be obtained by addition of AB plus BC plus CD plus DA. This addition will be called the perimeter of this figure. Today, let's learn to find the perimeter of enclosed figures made of squares and rectangles. Take a paper. Draw a square PQRS with side 5 cm on it. Can you tell what will be its perimeter? Think. Exactly. To find its perimeter, we have to add the lengths of all its 4 sides. But all the sides of square are equal. So, the perimeter of the square 4 multiplied by length of a side. If you know the length of the side of a square, then by using this formula, you can find the perimeter of that square. In this way, the perimeter of square PQRS will be 4 multiplied by 5 cm is equal to 20 cm. Now, you can draw a rectangle JKLM with 3 cm length and 2 cm breadth on paper. Can you tell me what will be the perimeter of this rectangle? Think. Here also, the perimeter of the rectangle will be sum of the lengths of all its sides. But the opposite sides of the rectangle are equal as JK is equal to LM and KL is equal to MJ. So, we can say that the perimeter of the rectangle is 2 multiplied by JK plus KL. If we term the side JK as the length of the rectangle and the side KL as the width of the rectangle, then the perimeter of the rectangle is equal to 2 multiplied by length plus width. If you know the length and width of a rectangle, then you can find the perimeter of that rectangle using this formula. For example, the perimeter of the rectangle JKLM will be 2 multiplied by 2 cm plus 3 cm is equal to 2 multiplied by 5 cm is equal to 10 cm. Now, imagine if we cut the square PQRS and the rectangle JKLM from paper and keep them adjacent, then what will be the perimeter of the new shape PQRKLM to be created? Think. Let me tell you. First of all, point S and point J are coming at each other. So, we will name only one of them. Like here, we will call this point as point S. Here, we get a new shape PQRKLM by putting both the shapes together. Its perimeter will be length of its boundary. To find out, we have to sum the lengths of all its sides. Here, PQ is equal to QR. The side of the square PQRS is equal to 5 cm. Can you tell how we can find the length of the RK? Think. Absolutely right. RK is equal to RS minus SK is equal to 5 cm minus 2 cm is equal to 3 cm. KL is equal to 3 cm. Similarly, LM is equal to 2 cm. Similarly, MP is equal to MS plus SP is equal to 3 cm plus 5 cm is equal to 8 cm. In this way, the perimeter of figure PQRKLM will be PQ plus QR plus RK plus KL plus LM plus MP is equal to 26 cm. Just think, can we add the perimeter of a square and the perimeter of a rectangle? No. If we sum their perimeter, then the result is 20 cm plus 10 cm is equal to 30 cm. The perimeters are different in both the cases. Therefore, it is wrong to derive the perimeter of the enclosed shape by the sum of the perimeters of shapes forming it. You must find out the reason for this by discussing it with your teacher. Now find out for yourself that if we enclose the rectangle in this way, or in such a way, will we get the same perimeter in each case? Today we have learned the perimeter of adjoining figures. In the next video, we will see some interesting examples related to them. Today we will see some interesting examples related to perimeter of adjoint figures. In the following figure, a square is connected at the midpoint of the side AD of the square ABCD. Find the perimeter of the figure. In the figure, it is given that length of the side of square ABCD is 8 cm. According to the question, G is the midpoint of side AD, so the length of the line segment AG and line segment GD will be equal, that is, AG is equal to GD. Looking at the figure, we can say that AD is equal to AG plus GD, that is, AG plus GD is equal to 8 cm. Since AG is equal to GD, GD plus GD is equal to 8 cm. Twice GD is equal to 8 cm, so GD is equal to 8 cm divided by 2 is equal to 4 cm. That is, the length of the side GD of square DEFG is 4 cm and the length of the side AG is also 4 cm. Perimeter is equal to sum of lengths of all sides. Therefore, we will add the lengths of all the sides of figure to find the perimeter. Perimeter is equal to AB plus BC plus CD plus DE plus EF plus FG plus GA. Perimeter is equal to 8 cm plus 8 cm plus 8 cm plus 4 cm plus 4 cm plus 4 cm plus 4 cm. Thus, the perimeter of figure shown is 40 cm. Next example, the perimeter of rectangle PQRS is 120 meter. Rahul divided the rectangle PQRS into 3 equal rectangles. Find the perimeter of each rectangle. Rectangle PQRS is divided into 3 rectangles of equal measurements. That is, the length and width of each rectangle are equal. Let us consider the length of each rectangle as L and width as B. Here, the perimeter of the rectangle PQRS is equal to the sum of the lengths of the 4 sides of the rectangle is equal to L plus B plus L plus B plus B plus L plus B, which is equal to 3L plus 4B. We are given perimeter 120 meter of the rectangle PQRS. So, we can say that 3L plus 4B is equal to 120 meter. Here, the side is PQ is equal to B plus B is equal to 2B and the side is RS is equal to L. Since the opposite sides of rectangle are equal, therefore, we can say that PQ is equal to RS, that is L is equal to 2B. That is, Now we can write 3L plus 4B is equal to 120 meters as 3 multiplied by 2B plus 4B is equal to 120 meter. By simplifying this, the value of B will be 12 meter. Since L is equal to 2B, L is equal to 2 multiplied by 12 meter. So we get the value of L is 24 meter. We know that the perimeter of rectangle is 2 multiplied by length L plus width B. Therefore, the perimeter of each rectangle is equal to 2 multiplied by 24 plus 12 meter is equal to 2 multiplied by 36 meter is equal to 72 meters. Next example. Perimeter of square ABCD is 84 cm. What will be the length of each side of a square in millimeters? We know that the perimeter of square ABCD is equal to 4 multiplied by length of a side. Therefore, the length of one side will be the perimeter of the square ABCD divided by 4, which is equal to 84 cm divided by 4 is equal to 21 cm. We know that 1 centimeter is equal to 10 millimeters. In this way, the length of one side of square ABCD will be 21 multiplied by 10 millimeters is equal to 210 millimeters. Since the length of all the sides of the square are equal, therefore, the length of each side of the square ABCD is 210 millimeters. Today we have seen some interesting examples related to perimeter of adjoint figures. In the next video, we will see some misconceptions related to them. Today we will see some misconceptions and common mistakes related to the perimeter of adjoint figures. Misconception 1. There is a square-shaped wire. Ria twisted the wire and converted it into a rectangle. Is the perimeter of square and rectangle different? The total length of the boundary of closed figure is called its perimeter. Some students think that if shape of wire is changing, therefore the perimeter will also change. Here, since the shape of the square has been converted to the shape of the rectangle, they think that the perimeter of square and the rectangle will be different. So, they give answer as option 1, which is a misconception. Here, the shape of wire is changing, but there is no change in the length of the wire. Therefore, the perimeter of both rectangle and square will be same. That is, option 2 is the correct answer. Misconception 2. What is the perimeter of the following figure? This figure is drawn on the square paper. While calculating the perimeter, students often count the squares along the sides of the figure. This gives result as 10 units. So, they answer option 1, which is a misconception. The total length of the boundary of closed figure is called its perimeter. So, we have to add the lengths of all the sides of this figure. By addition, we will get the perimeter of this figure as 18 units. Therefore, the perimeter of the given figure is 18 units. Hence, option 2 is the correct answer. Common mistake 1. Ignoring units. If students are asked to calculate perimeter of rectangle of length 4 meter and the width 100 centimeter, so they get the perimeter of rectangle is equal to 2 multiplied by length plus width, which is equal to 2 multiplied by 100 plus 4 is equal to 208 meter, which is an incorrect answer. They do not equate the units of length and width before determining the perimeter. For example, here the length of the rectangle is in meter and width is in centimeter. So first, we should equate length and width units. Since 100 centimeter is equal to 1 meter, the width of the rectangle is 1 meter. Thus, the perimeter of rectangle is 2 multiplied by 4 plus 1, that is 10 meter. This type of mistake can be avoided by reading the question carefully. Common mistake 2. Solving half questions. If some students are asked that the length of each side of a square field is 20 meter, so how much expenditure will be incurred on fencing at the rate of 140 rupees per meter? So, the children determine the perimeter of the square field 4 multiplied by 20 is equal to 80 meters. They forget to simplify the question further. Like here, they know the perimeter but forget to find the cost of the fencing. Expenditure on fencing is equal to 140 rupees multiplied by 80 is equal to 11,200 rupees. To avoid this kind of mistakes, one should solve the questions keeping in mind what has been asked in the question. Today we have seen some misconceptions and some common mistakes related to the perimeter of adjoint figures. Today we are going to learn about area of parallelogram. Take a squared paper. Now draw a parallelogram on it as shown. Now cut the parallelogram from paper. Draw the perpendicular from one of the vertices of this parallelogram on its opposite side. You will get this type of triangle. Cut and separate this triangle from the parallelogram. Keep this triangle on other side of the parallelogram as shown. Can you tell me which shape is obtained? Think. Absolutely true. It is a rectangle. Just think, will the area of parallelogram will be equal to the area of rectangle obtained? Think. Absolutely true. Since we have made the rectangle from parallelogram, only therefore, area of parallelogram and area of rectangle will be equal. We know that area of rectangle is equal to length multiplied by breadth. Here, length of rectangle is equal to length of base of parallelogram. The line on which perpendicular is made will be considered as base of the parallelogram. Similarly, breadth of rectangle is equal to height of parallelogram, which is the length of the perpendicular. Therefore, we can say that area of parallelogram is equal to length of base of parallelogram multiplied by height of parallelogram, or area of parallelogram is equal to base multiplied by height. If we consider length of base of parallelogram as b and height of parallelogram as h, then we can write area of parallelogram is equal to base multiplied by height. With the help of this formula, we can easily find out the area of parallelogram. Let's find out the area of parallelogram shown. Here, length of base of parallelogram is 6 unit and height of parallelogram is 5 unit. Therefore, area of this parallelogram will be 6 unit multiplied by 5 unit is equal to 30 square unit. Remember that in parallelogram, we can consider any side as its base. The length of the side which we consider as base will be the length of the parallelogram. On this side, the length of the perpendicular from the opposite vertex is called as the height of the parallelogram. Like in parallelogram EFGH, on side HG, perpendicular ED is drawn from the opposite vertex E. If we consider side HG of parallelogram EFGH as base and perpendicular ED as height, then we get area of parallelogram as HG multiplied by ED is equal to 30 centimeter multiplied by 12 centimeter is equal to 360 square centimeter. Similarly, we also see that in parallelogram EFGH on side FG, perpendicular EB is drawn from vertex E. Therefore, for parallelogram EFGH, base FG and perpendicular EB as height can be considered. From this, we get area of parallelogram as FG multiplied by EB is equal to 15 centimeter multiplied by 24 centimeter is equal to 360 square centimeter. In both situations, area is similar, which proves that any side of parallelogram can be taken as base and perpendicular on it can be taken as height of parallelogram. Now, you must have understood the area of parallelogram. Today we have learned the area of parallelogram. In the next video, we will see some examples on this. Today we will see examples on area of parallelogram. Find out the area of parallelogram PQRS shown below. In the given parallelogram PQRS, perpendicular PT is drawn from the opposite vertex P on side SR. Therefore, here we consider side SR as base. The perpendicular drawn on the base from the opposite vertex is called the height of the parallelogram. Therefore, perpendicular PT is the height of parallelogram PQRS. Can you tell me the formula to calculate area of parallelogram? Think. Absolutely correct. Area of parallelogram is equal to base multiplied by height is equal to B multiplied by H. In this way, area of parallelogram PQRS is equal to SR multiplied by PT. Since SR is equal to 5.6 cm and PT is equal to 3.7 cm, therefore, the area of parallelogram PQRS is equal to 5.6 cm multiplied by 3.7 cm is equal to 20.72 square centimeter. Next example. Perimeter of parallelogram DCBA is 0.2 meter. If the length of side BA of the parallelogram is 6 cm and height CE is 3 cm, then what is the area of parallelogram DCBA? Length of side BA of parallelogram is 6 cm and height of CE is 3 cm. Can we find out the area of parallelogram DCBA based on the given measurements? No. To find the area, we must know the length of height CE and base AD. Therefore, we have to find the length of base AD. We have given the perimeter of parallelogram DCBA as 0.2 meter. Since the length of side is given in meter, therefore, we need to convert the perimeter into centimeter. Here, perimeter of parallelogram DCBA is equal to 0.2 meter is equal to 0.2 multiplied by 1 meter is equal to 0.2 multiplied by 100 centimeter is equal to 20 centimeter. Here, perimeter of parallelogram DCBA is equal to DC plus CB plus BA plus AD. In parallelogram, measures of opposite sides are equal. Therefore, here BA is equal to DC is equal to 6 cm and CB is equal to AD. Therefore, perimeter of DCBA is equal to 6 cm plus 6 cm plus AD is equal to 12 cm plus 2 AD. From equation 1 and 2, 12 plus 2 AD is equal to 20. Solving this, we get twice AD is equal to 20 minus 12 means twice AD is equal to 8. Base AD is equal to 8 by 2 is equal to 4 centimeter. Since the area of parallelogram is equal to base multiplied by height, therefore area of parallelogram DCBA is equal to AD multiplied by CE is equal to 4 centimeter multiplied by 3 centimeter is equal to 12 square centimeter. Today we have seen examples on area of parallelogram. In the next video, we will see misconceptions on this. Today we will see misconception and common mistake related to area of a parallelogram. Misconception 1. Find out the area of parallelogram PQR is given below. Area of parallelogram is equal to base multiplied by height. Students often consider any side of the parallelogram as height. Like, they think that in parallelogram PQRS, side SR is base and PS is height. Therefore, the area of parallelogram is 6 cm multiplied by 3.5 cm is equal to 21 square centimeter. With this misconception, they give answer as option 1, which is wrong answer. Remember that any side of a parallelogram can be its base, and the perpendicular drawn on the base is the height of the parallelogram. In this parallelogram, we can see that the perpendicular is drawn on side QR. Therefore, QR can be taken as base and PT as height. With this, area of parallelogram is QR multiplied by PT. Here, QR is equal to PS is equal to 3.5 cm and PT is equal to 5 cm. Therefore, area of parallelogram is 3.5 cm multiplied by 5 cm is equal to 17.5 square centimeter. Therefore, option 2 is correct. Common mistake 1. Do not equalize units before calculating area. If students are asked that base of parallelogram is 1 meter and height is 50 centimeter, then what will be its area? Then on calculating the area, they ignore the units. Due to this, they get the answer as 50 square centimeter or 50 square meter, which is a wrong answer. While calculating area, it is necessary to make sure that units of quantities must be equal. Here we can write 1 meter is equal to 100 centimeter. Now the base is 100 centimeter and height is 50 centimeter. Therefore, area of parallelogram is 5000 square centimeter. Can you represent it in square meter? Try yourself. Today we have seen misconception and common mistake related to area of parallelogram. Parallelogram. Today we will learn about the area of triangle. A polygon made up of 3 sides is called a triangle. Let us understand the area of triangle with an interesting activity. Take a paper. Draw a triangle on it. We have drawn a triangle with sides 5 cm, 5 cm and 6 cm. Cut this triangle from paper. Draw a triangle on paper which is congruent to this triangle. That is, draw another triangle whose sides are of length 5 cm, 5 cm and 6 cm. Cut this as well. We see that under a correspondence, the two triangles completely cover each other. Therefore, we can say that the area of these two triangles is equal. Generally, the area of all congruent triangles is equal. Can you tell me how we will find the area of triangles? Think. Let me explain you. We will place both pieces of congruent triangles together in such a way that a pair of their corresponding sides is joined. You can do it in this way, or this way. By doing this, you will get a quadrilateral. Which type of quadrilateral is this? Think. The opposite sides of this quadrilateral are parallel and equal. Therefore, this is a parallelogram. In the previous video, we learned that the area of parallelogram is equal to base multiplied by height, where base is one side of the parallelogram and height is perpendicular dropped on that side from the opposite vertex of a parallelogram. Since the parallelogram is made up of two congruent triangles, therefore, the area of the parallelogram will be equal to the sum of the areas of two congruent triangles. Since the area of both triangles is equal, so we can say that area of parallelogram is 2 multiplied by area of triangle, that is, area of triangle will be the half of area of parallelogram. In this way, the area of each triangle is half multiplied by base multiplied by height, in which base is one side of the triangle and height is the length of perpendicular dropped on that side from the opposite vertex. On measuring, you will find that this height is 4 cm. Since the length is 6 cm and the height is 4 cm, so the area of each triangle is equal to half multiplied by 6 cm multiplied by 4 cm is equal to 12 square centimeter. If we consider the base of the triangle as B and the height as H, then we can say that the area of the triangle is equal to half multiplied by base multiplied by height, or half BH. Now look here, two triangles are shown here. Can you find the area of these triangles? Try it. Area of triangle ABC is equal to 420 square centimeter. Similarly, the area of triangle XYZ is also equal to 420 square centimeter. Here, the area of both triangles is equal. Can we say that they are congruent? Think. Absolutely right. They are not congruent because their measurements are different and they do not cover each other completely. In short, if two triangles are congruent, then their area must be equal. But it is not necessary that triangles equal in area are congruent. So, now you must have understood the area of the triangle. So today we have learned about area of triangle. In the next video, we will see some examples related to the area of triangle. Today we will see some interesting examples related to area of triangle. Find out the area of following triangle XYZ. In this obtuse angle triangle XYZ, the line segment XO is perpendicular on the opposite sides YZ of the vertex X. If we consider YZ as the base of the triangle and XO as the height, where XO is equal to 2.8 cm and YZ is equal to 4.6 cm, so the area of triangle XYZ will be equal to half multiplied by base multiplied by height is equal to half YZ multiplied by XO, that is half 4.6 cm multiplied by 2.8 cm. On solving this, we get the area of triangle XYZ as 6.44 square centimeter. We can solve it in another way also. In triangle XYZ, line segment YW is perpendicular on side XZ. In triangle XYZ, If we consider side XZ as base and perpendicular YW as height, then the area of triangle XYZ will be half XZ multiplied by YW, that is, the area of triangle XYZ will be 6.44 square centimeter. Here, in both cases, we have considered different sides as base, and by considering their corresponding perpendicular, we have calculated the area. In both the cases, we have got an equal answer. Can you tell the reason behind this? Think. Let me tell you. This is because in both cases, we have taken the same triangle to find out area. If we consider any side of the triangle as base and its corresponding perpendicular as height, then it will not change the area of the triangle. Therefore, in both cases, the area of the triangle is same. So, with the help of the length of one side of the triangle and its corresponding height, the area of the triangle can be calculated. It is not necessary that the length of all sides should be known. Next example. Below is triangle ADB of area 30 square centimeter and triangle ADC of area 54 square centimeter. The line segment AD is perpendicular on BC. If BD is 5 centimeter, then find the measurement of line segment AD and line segment DC. It is given that the area of triangle ADB is 30 square centimeter and the area of triangle ADC is 54 square centimeter. In both these triangles, AD is common. We know that the area of the triangle is half multiplied by base multiplied by height. In this way, if we know the measurement of the area of the triangle, base or its corresponding height of any two from these three, then we can easily find the measure of the third, such as the area of triangle ADB is 30 square centimeter. Since the side BD and side AD are perpendicular to each other, this means that angle ADB is the right angle. That's why triangle ADB is a right angle triangle. In case of right angle triangle, we can consider one of these perpendicular sides as base and the other side as height. Here we will consider the side BD as base and side AD as height. In this way, we can write area of triangle ADB is equal to half multiplied by BD multiplied by AD. We know the area and measure of side BD. So, we can find the measure of AD. For this, we will arrange the equation multiplying both sides by 2 and dividing by BD. We get area of triangle ADB multiplied by 2 divided by BD is equal to AD. We can write this as AD is equal to area of triangle ADB multiplied by 2 divided by BD. Since the area of triangle ADB is 30 square centimeter and the length of line segment BD is 5 centimeter, that is, we get AD is equal to 12 centimeter. In triangle ADB and triangle ADC, side AD is common. Since in triangle ADC, AD and side DC are perpendicular to each other, we can say that triangle ADC is also a right angle triangle. Here also, we can consider either the side AD and DC as base and the other as height. Let's consider side DC as base and AD as height in triangle ADC. We can write the area of triangle ADC is equal to half multiplied by DC multiplied by AD. Therefore, DC is equal to area of triangle ADC multiplied by 2 divided by AD, which is equal to 54 multiplied by 2 divided by 12 centimeter. In this way, we will get DC is equal to 9 centimeter. Today we have seen some interesting examples related to area of triangle. In the next video, we will see some misconceptions related to area of the triangle. Today we will see a misconception and an example related to area of triangle. Misconception: find out the area of following triangle ABC. The formula of area of triangle is area of triangle is equal to half multiplied by base multiplied by height. Some children consider side BC as base and other side as height of triangle. Like here, they consider side AB as height that results in an area of triangle as 21 square centimeter. But it is a misconception. That is, option 2 is the wrong answer. Here, side AB is not perpendicular on base BC. Therefore, we cannot consider it as height. The height of the triangle is perpendicular distance from the opposite vertex of base. Here it is given that perpendicular distance from vertex A to base BC is 5 cm. So we can take the height of triangle as 5 cm. Therefore, the area of triangle ABC is half multiplied by 6 cm multiplied by 5 cm is equal to 15 square centimeter. That is, option 1 is the right answer. Next example. Ramesh's rectangular farm is of the length 48 meter and breadth 16 meter. He constructed 24 right-angle triangles, flower beds of same size throughout his farm. If the base of each right-angle triangular bed is 8 meter, then what will be its height? Since the length of rectangular farm is 48 meter and breadth is 16 meter, therefore the area of farm will be length multiplied by breadth is equal to 48 meter multiplied by 16 meter is equal to 768 square meter. This area is divided into 24 equal triangular flower beds. Therefore, we can say that the area of each bed will be 24th part of the rectangular area. That is, the area of each right-angle triangular bed is 768 square meter divided by 24 is equal to 32 square meter. In the right-angle triangle, two sides are perpendicular to each other. We can take one of these as base and other as height. Since the area of the right-angle triangular bed is half multiplied by base multiplied by height, therefore, we can say that height of right-angle triangular bed is equal to area of the right-angle triangular bed multiplied by 2 divided by length of base. It is given that the length of base of right-angle triangle is 8 meter. Therefore, its height will be 32 square meter multiplied by 2 divided by 8 meter is equal to 8 meter. So, in Ramesh's field, the height of each right-angle triangular bed is 8 meter. So today we have seen a misconception and an example related to area of triangle. Today we will learn about circumference and area of the circle and semicircle. We know that the total length of the boundary of a closed figure is called its perimeter. In the context of a circle, we call it a circumference. That is, the length of the boundary of a circle is called its circumference. We denote it as C. Let us perform an interesting activity to know how to find the circumference of a circle. Take a cardboard. On this, draw a circle of radius 3.5 centimeter. Cut the drawn circle. Can you tell how we can find out length of the boundary of the circle, that is its circumference? Think. Of course, ruler cannot be used here because ruler is used to measure the length of a straight line. Since the boundary of the circle is curved, we cannot find the length of its boundary with the ruler. To find the length of the boundary of the circle, mark a point on the boundary and place a thread on this point and move it along the edge of the circle. The length of the thread required to reach the starting point, that is, to make a complete round, gives us the idea of circumference of the circle. In this case, the circumference of circle is 22 centimeter. There is an interesting relationship between the diameter and the circumference of the circle. If we find the ratio of the circumference of any circle to its diameter, then in each case it is 22/7. This ratio is constant, which is represented by pi. In decimal, pi is 22/7 is approximately equal to 3.14, which shows that the circumference of the circle is more than 3 times the diameter. If we represent the circumference by c, the diameter as d, then pi is equal to c by d. This gives us the formula to find the circumference of circle. C is equal to pi d. Since the diameter is twice the radius, that is, d is equal to 2r, that's why we can write the same formula as c is equal to 2 pi r. This formula is very useful for finding the circumference of a circle. Like here, the radius of circle is 3.5 centimeter, so the circumference of circle will be c is equal to 2 multiplied by 22/7 multiplied by 3.5 centimeter is equal to 22 centimeter. Now, let's talk about the area of a circle. We know that the surface enclosed by a plane of closed figure is called its area. Let us find the area of this circle by an activity. Suppose we have taken a circle of cardboard. We will consider its radius as r. First, we will divide this circle into 8 equal parts. Now, we will cut these parts and separate it. We will arrange these parts in this way. From this, we will get a shape like a parallelogram. If we divide the circle in 16 equal parts and arrange it in this way, then we will be able to arrange the parallelogram more properly. In this way, the more equal parts, the more appropriate is the parallelogram. If we divide the circle into several equal parts by arranging them, we will get a rectangle. Remember that a rectangle is also a parallelogram. The breadth of this rectangle will be equal to radius r of the circle and the length will be half the circumference of the circle, that is pi r. We can say that area of circle is equal to area of rectangle made. That means here area of circle is equal to length multiplied by breadth is equal to pi r multiplied by r is equal to pi r square. Area of circle is equal to pi r square. From this formula, we can find the area of any circle. For example, by using this formula, we can find the area of a given circle whose radius is 3.5 centimeter. The value of pi is 22/7 and the value of r, that is radius, is 3.5 centimeter. By putting these values in this formula, we will get the area of this circle as 38.5 square centimeter. Now, suppose we have to find the circumference and area of the semicircle of the same radius, then how will we do this? Think. Let me tell you, semicircle means half of the entire circle. Therefore, the area of semicircle will be the area of entire circle divided by 2, that is half pi r square. In this way, taking radius r is equal to 3.5 and pi is equal to 22 by 7, we will get the area of this semicircle as 19.25 square centimeter. Similarly, the circumference of the semicircle is half the circumference of the circle. So, the circumference of the semicircle will be pi r. In this way, by taking r is equal to 3.5 and pi is equal to 22 by 7, we will get the circumference of this semicircle as 11 centimeter. Today we have learned the circumference and area of circle and semicircle. In the next video, we will see some examples related to this. Today we will see interesting examples on circumference and area of circle and semicircle. The radius of a circular table is 42 cm. Find the circumference and area of the table. For convenience, take pi is equal to 22 by 7. The radius of a circular table is r is equal to 42 cm. Since the circumference of a circle is c is equal to 2 pi r, hence the circumference of circular table is 2 multiplied by 22 by 7 multiplied by 42 cm is equal to 264 cm. Similarly, to find the area of a circle, we will use this formula. Hence, the area of circular table is 22 by 7 multiplied by 42 cm multiplied by 42 cm is equal to 5544 square centimeter. Let's see the next example. If the radius of a semicircular ground is 35 meter, then find the cost of a fencing the boundary of ground at a rate of rupees 75 per meter. The radius of semicircular ground is r is equal to 35 meter. To find the total cost of fencing, we should find the length of the boundary of this ground. That means we have to find the perimeter of this ground. By looking at the figure, we can say that to find the perimeter of this ground, we have to add the circumference and length of the diameter of the semicircle. We know that the circumference of a semicircle is pi r and the diameter is twice the radius 2r. So we can say that the perimeter of semicircular ground is pi r plus 2r. By putting all the values in the formula and simplifying it, we get the perimeter of semicircular ground as 180 meter. Since the cost of fencing is rupees 75 per meter, therefore the total cost of fencing 180 meter will be 180 meter multiplied by rupees 75 per meter is equal to 13,500 rupees. Today we have seen some interesting examples related to circumference and area of circle and semicircle. In the next video, we will see some more examples related to this. Today we will see some more examples related to circumference and area of a circle and semicircle. The circumference of a circular garden is 220 meter. Around the garden, there is a 3 meter wide path. Find the area of a path. For the given information, we can draw a figure like this. The inner circle in the figure represents the boundary of the garden and the outer circle represents the outer boundary of the path. The area between these two circles represents the area of the circular path. We have to find the area of this path. We see that area of the path is included in the area of the outer circle but not included in the area of the inner circle. This means that to find the area of the path, we should subtract the area of the inner circle from the area of the outer circle. So let's start. Let's consider the radius of the inner circle as R1 and radius of outer circle as R2. According to given information, the circumference of the inner circle is 220 meter. Since the circumference of the circle is C is equal to 2 pi r, therefore here 2 pi r1 is equal to 220 meter. So it is 2 multiplied by 22 by 7 multiplied by r1 is equal to 220 meter. By dividing both sides with 2, we get 22 by 7 multiplied by r1 is equal to 110 meter. Similarly, by multiplying both sides with 7 by 22, we will get r1 means radius of the inner circle is equal to 35 meter. Now, can you tell what will be the radius of R2 of the outer circle? Think. Absolutely right. To find out radius of the outer circle, we need to add the width of the part with the radius of the circular garden. That is, radius of outer circle R2, 35 meter plus 3 meter is equal to 38 meter. Since area of circle is pi r square, therefore here the area of inner circle will be pi r1 square and the area of outer circle will be pi r2 square. If we subtract the area of inner circle from the area of outer circle, then we will get the area of desired path. That is, area of path will be pi r2 square minus pi r1 square. Here we can take pi as common. Since the radius of inner circle R1 is equal to 35 meter, radius of outer circle R2 is equal to 38 meter and the value of pi is 22 by 7. Therefore, we will get the area of path as 688.29 meter square. Next example. The length of one side of square banner is 56 cm. If a semicircle with maximum diameter is cut from this paper, then find the area of the remaining part. A semicircle with maximum diameter in a square is possible only when the length of diameter of the semicircle and the length of the side of the square are equal. Therefore, here the diameter of circle will be d is equal to 56 cm. In this way, the radius r will be half of the diameter, that is 28 cm. We have to find the area of the remaining part of the square paper except the area of the cut semicircle. We can get this by subtracting the area of semicircle from the area of the square. Here, area of a square is length of one side square, which is equal to 3136 square centimeter. Similarly, we get an area of semicircle with a radius of 28 centimeter as 1232 square centimeter. By cutting the semicircle in this way, the area of remaining part of square will be area of square minus area of semicircle is equal to 3136 square centimeter minus 1232 square centimeter is equal to 1904 square centimeter. Today we have seen some more examples related to circumference and area of circle and semicircle. Circle.